When we run OSPF on an NBMA topology like frame relay, what we get is often controlled by the interface type. Now, it's going to be of type serial, but if it is multi-point in nature, whether that be point-to-multipoint subinterface or the major interface, the default media type or the default network type is called non-broadcast. Let me show you that. If I do a show IP OSPF interface on my interface that is going to the frame relay cloud, you'll see network type non-broadcast. Now, this is really the most challenging network type to run OSPF on. And here's the deal. We have challenges with neighborship formation. We have challenges because we want to run a designated router in this media type, but we don't necessarily get the designated router in BDR that we would choose. We need the hub router to be the designated router, but we have to control this ourselves. So this is the most important place of all to control the designated router in any network. It doesn't really matter if it's an SVI going down to VLANs, but it does matter in multipoint frame relay. So let us make this work for us. Now I want you to see something really interesting. R4 is the hub topology, or the hub of the topology. And we've got a newly formed adjacency. I'm going to rerun this, and I wanted you to see that R4 is the BDR. This is not good. We need R4 to be the DR. So how is this going to work for us? Well, let's see if we can make this work properly. And I'll show you the way that we're supposed to do this. So first I'm going to do a show IP, or I'm going to do an IP OSPF priority 128. Hey, that's good. You know what? I'm going to do 255. And then I'm going to go to R5 and 6, and we're going to give them a priority on their interfaces of 0. IP OSPF priority 0. And remember, priority 0 means we can't be the designated routers. Keep on doing this. IP OSPF priority 0. Okay, so R5 has a priority of 0. R6 has a priority of 0. R4 has a priority of 255. That is the most extreme. We have weighted in favor of R4 being the designated router. Now, this isn't going to change unless we clear the process. But is it going to respect our configuration? So we'll do a clear IP OSPF process, say yes, and we'll give it some time. I'll be waiting here for a moment. Now I've waited a good, let's say, 90 seconds for the clear to take effect. Let's look at our interfaces now. Do a show IP OSPF on that interface. Is it respecting our configuration? Yes, it is. Now, this is a very good thing. This is a very good thing because it took my configuration. I will be honest with you. This is a little bit more flaky. And so you might want to get all of your ducks in a row and also do this. I'm going to show you one last thing. It says you can also configure your OSPF neighbors manually. You would only do this in a frame relay multi-point environment. But the command would be this. This says I don't want to form adjacencies via multicast. I'm going to do it via unicast hellos. And then you would specify your neighbor's IP address, and you can state their priority. So if you really want to control this, you can, and I'll do this also. I didn't need to do this, but I want you to see what they were talking about. These are what are called neighbor commands, and they ensure that we'll send hellos to the unicast destination address, and we'll say, hey, you should be priority 0. That indicates the priority of the neighbor with this command.